Good morning, everyone. Myself, I am Chaitanya, Deputy Director, National Water Academy, Central Water Commission, Pune. I welcome you all to this training program through distance learning on Introduction to Python Programming and its applications in water resources sector. I will be acting as a course director for this training program. This training program is designed as an introductory or foundational program for water resources professionals, including in-service engineers, who have some basic understanding of the concepts of programming, geographical information systems, that is GIS, and remote sensing. As you may be aware, Python is a general purpose language which has high presence in GIS industry. Python with its standard libraries and many of the third-party packages is very useful for data analysis and geospatial analysis purposes, and therefore it has great utility for water resources professionals. In this training program, we will be concentrating mostly on the basics of the Python programming. For the coming 5 days, in the first 2 to 3 days, we will be concentrating on the basics. Today, we will start with introduction to the Python programming in the first session. Along with, we will also install Python on our systems using Anaconda distribution. In the subsequent sessions, we will be covering data types, data structures, functions, loops, control flow in Python, error handling in Python, file handling in Python. We will also have a session on overview of object-oriented programming by a guest faculty. Thereafter, we will introduce you to some Python packages which are useful for data analysis purposes. We will have a session on pandas, which is useful for analysis of tabular data or any structured data. There will be a session on handling vector data using GeoPandas third-party package. Then there will be a session on handling of raster data using rasterio or rasterstats third-party packages. We will also have sessions on data visualization using Python and QGIS customization by guest faculty towards the end of the program. Coming to the timings of this training program, we will be following a flexible approach, flexi approach. There will not be any fixed timings for the sessions. As per the schedule of the training program, we will be uploading the training recorded sessions and Jupyter notebooks and other material on NWS e-learning platform, and participants may follow them up as per their convenience. We will also have some live sessions for clearance of doubts and for other queries. The material will remain available, will remain accessible for the participants even after completion of the training program. We will be providing sufficient time period to review and practice, do the self-practice using the Jupyter notebooks provided to the participants. We will be using Jupyter notebooks all through this training program for writing and executing small snippets of the codes. They will be shared with the participants. Participants will be given 10 days time period after the completion of the training program for attempting an assessment test, and those participants who complete the assessment test will receive e-certificates on their registered email IDs. There will also be a WhatsApp group which will be created, which will be used for making announcements and also for answering any queries related to the content of the training program as well as other miscellaneous queries. The WhatsApp group will remain active even after completion of the training program. Also make use of the course forum which will be available on the e-learning platform for raising your queries, which can be answered by faculty members as well as other participants. So let us start with the first session of the program.
Clear understanding of hydrological processes, assessment and monitoring of various components of hydrological cycle are essential for sustainable development and management of water resources. Hydrological parameters such as precipitation, evapotranspiration, river discharge, soil moisture change, groundwater storage change, snow cover change, all these comprise of terrestrial water storage change. They all play an important role in the water and energy balance at any spatial scale. Understanding monsoon rainfall pattern and components of hydrological cycle It has assumed greater importance in the context of growing sectoral water demands and climate change predictions. Measurement of hydrological parameters and their quantification through traditional methods of measurements, such as point measurements, such as rain gauges, gauge and discharge stations, as well as retrieval of hydrological parameters from remote sensing imagery. It will naturally yield huge volumes of data. Long-term data sets at various spatial and temporal scales serve as inputs to process-based hydrological models for better estimation and forecasting of hydrological parameters. In other words, water resources professionals and researchers, they must deal with humongous amounts of data. Often raw data doesn't convey the right kind of information and may not be of much utility for analysis and decision making. Therefore, data preparation, data manipulation, data analysis, data visualization, and data presentation, they become very important, especially for decision making. With Python, we can handle any kind of structural data, whether it is in the tabular form or spreadsheets, whether it is in the form of multidimensional arrays. We will be seeing that raster data in the form of satellite imagery, it is represented as multidimensional arrays. Then Python can deal with relational databases wherein multiple tabular data are interrelated by key columns. It can deal with the time series data that we come across, whether evenly or unevenly spaced. Python with active support, Python programming with active support of user community and open source third party libraries. It has become very popular choice for data analysis tasks. Just to illustrate the point that raw data often fails to convey the necessary information. This data pertains to temperature anomaly that have been observed over a long period of time. But we cannot make anything out of this data. We cannot derive any useful information. When the same data is plotted as a time series plot uh, and presented as a time series plot, we can derive meaningful information of how the temperature anomaly has varied over a period of time. And when you add spatial context to the data and present it in the form of spatial map, it adds much more value to the information provided by the data. Someone has utilized the same data and presented temperature anomalies by country-wise between years 1880 to 2017. Thereby, one can visualize the data across space and time. This has been done, this animation was done using Python. That brings us to the point of geospatial analysis and its importance. Our planet is undergoing environmental changes that have never been seen in recorded history. Parallelly, open access data and software have become more widely available to everyone, especially in last few years. Geospatial analysis is the best approach to understanding our world more efficiently and deeply, as we have just seen how adding spatial context to the data provides valuable information. Geospatial analysis can answer critical questions at the heart of the choice to be made and often cannot be answered any other way. Then the question comes, why use programming language when we have access to GIS softwares? When modern geospatial analysis can be conducted with the click of a button in any of the easy to use commercial or open source GIS software such as ArcGIS or QGIS respectively. The answer to that question is You want to have complete control of the underlying algorithms, data, and execution. And more importantly, you want to automate specific repetitive tasks, which is not otherwise possible with GIS softwares. Say you want to mosaic tiles of satellite imageries over a long period of time, or you want to uh, derive time series of NDVI of a particular location from daily satellite imagery, or you want to conduct change detection analysis over a long period of time. Such things you can such workflows can be conducted using making use of programming language. You want to learn program that is easy to share with others users so that they also improve upon and add value to it, and you want to learn geospatial analysis beyond pushing buttons in software. Then comes the question of why only Python programming language but not any other computer programming language. Python was created in early 1990s but has become more popular lately, coinciding with the time period of increased access to open access datasets and software. We are viewing Python applications from the standpoint of data analysis requirements. So some of the notable features of Python are it is a full spectrum language, meaning you can start with the basics, and as you go along, when you get conversant with the language and when the requirements increase, you can adopt its advanced features without having the need to shift to any other language for building applications. It is a very good language for beginners because of its elegant syntax, which is easier to read and write. Whereas other powerful programming languages like C++, they have a somewhat intimidating syntax for beginners who are new to programming. It is an interpreted language which can be picked up for running short snippets of code and get your program working without getting lost in the problems of compilation. Python is a high-level language, and all high-level languages need to be converted to low-level languages which are understandable to machines. And this can be done either through compilers or through interpreters. Python, in contrast to compiled languages, is an interpreted language. Python comes with its inbuilt integrated development and learning environment, and Python can be used with many other integrated development environments, and its interactive mode makes it easy to test short snippets of code. In this course, we will be using Jupyter notebooks later, where you will see how you can write and execute um, short snippets of code at ease. Python comes with a large standard library which can be used for doing all sorts of tasks, and these libraries are extendable by adding new modules implemented even in a compiled language such as C or C++. Python can also be embedded into an application to provide a programmable interface. Python is portable. It runs everywhere from Linux to Mac and to Unix to Windows. It runs in across all operating systems, and you can share the code with any user. Only thing is the one has to install the required modules on the system to get the code running. It is free and open source. It doesn't cost anything to download or use Python or to include it in your application. It can be freely modified and redistributed. The benefits of open source is it comes along with source code which you can modify and redistribute and use wherever you want. Another use of open source softwares is it also comes with an active community support, which is useful for addressing bugs and other issues related to the language. Any problem that you come across while executing a program, you can find solutions at very easily, as there is an active user community support which is available online. For example, through portals such as Stack Overflow, etc. Again, just to illustrate the point of elegant syntax, which is easier to read and write. It is customary for those learning programming to write printing hello world as the first program. Now, the same program of printing hello world in C++, and Python is shown here, and you can see the syntax of C and C++ is for newcomers, it will be a bit intimidating, whereas Python, it is like English language, which is simpler to read and write and understand. It is as simple as reading English language. These are some of the programming language features of Python. There is a variety of basic data types and structures available in Python. We will be seeing about data types tomorrow. Python supports object-oriented programming paradigm. We will see what is object-oriented programming paradigm later this week. Python code can be grouped into modules and packages. Error handling in Python is cleaner and is easier. Python has other advanced programming features such as generators, list comprehensions. The Python's automatic memory management frees you from having to manually allocate and free memory in your code. These are some of the features which are better understood by those who are already conversant with programming. Coming to the installation of Python, you may already have Python installed on your system through OS other than Windows or through GIS software. If it is part of OS and is used by the OS, it is known as System Python, which is generally out of date. Python installer files are available for download from this URL python.org, where you will find all the current latest release as well as previous releases of Python installer files available for download. The latest release which is available for download is Python 3.10.7. However, we will not be installing from here. We will be instead installing Python as part of the Anaconda package manager, as we are more concerned about installing the third-party packages, Python packages, which will be useful for data analysis and geospatial analysis. We will be installing those packages in a secluded environment after creating the environment, which we will be seeing in a while from now. Just to give an idea of how online Python interpreter looks like, you can launch online Python interpreter by clicking on this launch interactive shell on the portal, which will load online Python interpreter of version 3.10.5, which was released in July 2022. Now, after this command prompt, you can type any short line codes and execute by pressing enter on the keyboard. You can even print a statement, any statement, as is customary for the beginners learning any programming language. We can write this program of printing hello world onto the console. So in this way you can write code and then execute them on this online Python interpreter. You can exit the console with the command exit and parenthesis. So all the releases, all the previous releases for Windows are available, depending upon whether your system is a 32-bit system or 64-bit system. You can look for earlier releases of Python. The latest one which is available is the version 3.10.7. Python 2 is no longer being supported. The last version of the Python was 2 was released in April 2020 of version 2.7.18. Since it is no longer supported, it is not a good idea to start any project using Python 2. Then under documentation, you will be finding the documentation for the latest version available, 3.10.7. There is a tutorial um, available and you may have a look, which will be useful. And also there are a few other links which are available for beginners, like this beginner guide, which has many resources listed out for learning Python. Before going ahead with installation of Anaconda distribution and Python packages using Anaconda distribution, let us understand few terms. Even if you don't understand these terms, there is nothing to worry. You may proceed with installation of Anaconda distribution, and you may revisit the coming three slides afterwards for improving your understanding. Now, what is actually is Anaconda distribution? Anaconda distribution is an easy to install collection of high performance Python libraries along with Conda, which is an open source package and environment management system. In other words, Anaconda distribution is a collection of high performance Python libraries plus Conda, which is a tool for finding, installing, running and updating the packages, Python packages along with their dependencies. Here we are using libraries and packages interchangeably. So because Python being an open source software, so many users are developing um, many packages for specific purposes. Um, Multitude of packages are being developed, modified and redistributed by the users. Some of them become very popular because of their high utility. So many packages are there, and if a package was developed on the basis of a previous version of Python, along with other dependencies. Dependencies may include other packages like the GeoPandas is dependent upon Pandas, which is used for GeoPandas is used for vector data analysis. Similarly, Rasterio, which is used for raster data analysis, it is dependent upon another package, another popular numerical Python NumPy package. So all these packages are have their interdependencies, which are they may be dependent upon a different version of Python, or they may be dependent upon a different version of another package. So it may be leading to conflicts if there are many versions of Python on a computer. So Conda, which is a tool for package and environment management, it can set up a separate environment to run the different version of Python for running that package while continuing to run the current version of Python outside in the normal environment. Why do I need Anaconda distribution? As said, many scientific packages require a specific version of Python to run. It's difficult to run various Python installations on one computer from interacting and breaking, and harder to keep them up to date. Anaconda distribution makes management of multiple Python versions on one computer easier and provides a large collection of highly optimized, commonly used data science libraries to get you started faster. The takeaway from this slide is Anaconda distribution has has a collection of scattered high performance Python libraries at one place, and it also has a tool called Conda, which is used for managing those packages, those Python packages, and while creating environment for running those packages without conflicting with other versions which are on the same computer. Then coming to the term environment, what is an environment? An environment is nothing but a folder or directory that contains a specific collection of Python packages and their dependencies so that they can be maintained and run separately without interference from each other, as stated in the previous slide. You can have multiple versions of Python installed on your system, and multiple versions of Python and multiple versions of third-party packages installed on your system within isolated environments, which will avoid conflicts. It is a good practice to create separate environment whenever you are starting a new Python project. So the takeaway from these paras is that we have to create separate, it is better, it is always better to create separate environment for any new Python project, and you install all your packages in that environment for the task at hand. Then what is a channel? A channel, Conda channel, these are the locations where the packages are actually stored. It is the repository of all the packages. They serve as the base for hosting and managing packages. Conda packages are located from remote channels, which are URLs to directories containing Conda packages. Now, different channels can have same package, and so Conda must handle these channel collisions. So it is a good practice to always install packages from the same channel to the extent possible. So the takeaway from here is that we have to install all packages from the same channel to the extent possible. We have to create a separate environment for a new project, Python project, and we have to install all packages in that environment from the same channel. Conda Forge is a community channel made up of thousands of contributors that provides Conda packages for a wide range of software applications. Now, before creation of this community channel called Conda Forge, locating packages was very difficult because multitude of users were developing and redistributing the packages, and they are scattered over many channels. And combining packages across channels was not always possible due to binary incompatibilities. And packages were only available for architectures the developer was interested in or had access to. And channels were often abandoned, updating required locating new channels. After Conda Forge community channel was created, all packages are shared in a single channel. Care is being taken that all packages are up to date, and common standards ensure that all packages have compatible versions. So we will be using Conda Forge channel for installing the packages. We will create a separate environment, and we will install useful Python packages for our purpose from Conda Forge channel. Suppose if a package is not available from Conda, then you may be able to find it elsewhere via Conda Forge or by using another package manager like pip. However, it is not advisable to mix Conda and pip for installation of packages unless strictly necessary. Another takeaway here is we should always try to use one package manager that we must use because we are installing Anaconda distribution and installing various packages using Conda tool. We should always try to install packages using Conda only. And if for non-Conda packages, If it is necessary, we have to go for another package manager called pip. So for this course, we will be installing Python from Anaconda distribution as part of Anaconda package manager, and then we will create a new environment. We will name it as Python-WRM, short form for water resources management, for installing various packages from Conda Forge channel. So that is that final conclusion, that we will be creating a new environment Python-WRM for installing various packages, Python packages from Anaconda distribution from Conda Forge channel. Coming to the actual installation of Anaconda distribution, in the slides provided to you, you will find a hyperlink Anaconda installer for Windows, which will direct you to the Anaconda distribution portal, where you will find the Windows 64-bit graphical installer file of Anaconda distribution individual edition. The installer file, as you can see, it itself occupies around 600 MB space. It is preferable to save Anaconda in C folder under users. Make sure that you have sufficient space available. You will minimum you will be requiring about 3.5 GB space for installation of Anaconda distribution. In case if you are short on space, you can go for Miniconda. You can search on Google for Miniconda, which is a much smaller installer with minimal number of open source packages, whereas Anaconda comes along with a collection of many open source packages. Miniconda has the Conda tool, Python, and some very small number of useful packages. So once you download the installer file, you can double click to launch it, which and follow the steps as shown in these screenshots. You agree the license agreement and then select installation for just me, which is recommended. Otherwise, you will be requiring admin privileges for installation for all users. Now continue to the next step, where it will ask you to choose install location. The setup file will install Anaconda 3 in the folder chosen by you, the destination folder. You can browse and select. You can choose C drive users and then name of the user. In my case, the name of the user is comp109. Once you select the destination folder, all the installation files along with Python 3.9 version and many third-party open source Python packages will get installed along with Anaconda distribution in the folder. As you can see, the space required is about 3.5 GB for completion of the installation. However, it is recommended to keep more space available so that we can install more third-party packages useful for data analysis and geospatial analysis, other than those which are getting installed with Anaconda distribution. Now make sure that none of the folders or subfolders have any spaces in their names. And once you click next, it will ask you for a selection of advanced installation option on how Anaconda integrates with Windows. Keep the default options as they are. In case if you have Python installed earlier on your system, then Anaconda 3 will not be automatically detected as a default Python. So make sure that you check this option, register Anaconda 3 as my default Python 3.9, which will make Windows automatically detect Anaconda as a primary Python 3.9 on the system. You leave out this option, add Anaconda 3 to my path environment variable. In case if you want to add Anaconda 3 to path environment variable in future, you can always do that even after completion of the installation. Only difference is that when you are registering Anaconda 3 as my default 3.9 option, every time you have to launch Anaconda 3 command prompt for launching the Conda installer using Python. Whereas if you have added Anaconda 3 to the path environment variables, you can directly use the command prompt. Now once you click on install, it will take some time for installation purpose. Now when the installation is done, it will show you this dialog box. you can click on next. Uh, for this training program, actually it is suggesting you to download data spell, which is an integrated development environment, or it may ask for downloading PyCharm. These are all various integrated development environments designed for working with Python for data analysis purpose. However, in this program, we will be not be using PyCharm or Dataspell IDEs. We will be using Jupyter notebooks. Then you click next and you finish the installation. Once you completed installation of Anaconda distribution, you can verify whether it is installed or not on your system by opening up Anaconda command prompt from the startup menu. You can type Anaconda prompt and then open this command prompt, Anaconda prompt, from the startup menu. You can type the command conda space dash dash version, and if it returns some version of Conda, that means Conda package and environment manager tool has been successfully installed along with Anaconda distribution. As you can see, it has returned Conda version 4.12.0. You can get further information about the Anaconda distribution that has been installed using this command conda space info, which provides information about the current active environment, which is base, that is the default root environment. At any time in the Anaconda prompt, the active environment will be placed, will be preceding the command prompt line within the parenthesis. As you can see, within the parenthesis here, on every line of the command prompt, you will find base. This is the current active environment. There is no other environment that has been created. Now, during this training program, as discussed earlier, we will be creating our own environment and we will be installing many Python packages to avoid incompatibility of the packages, or to avoid collisions between various versions of the packages and various versions of Python which may be there, and as well as packages which may be there on your system. So we will be doing it in a while, where you can also find information about the Python version here, 3.9.12, which has been installed along with Anaconda distribution. You can get a list of all the Python packages which have been installed along with Anaconda distribution using this command conda space list. So all these packages which will be listed are installed along with Anaconda distribution in the base environment. In case if you have used Miniconda, you will not be finding so many packages getting installed along with Python and Conda package and environment manager tool. Among the installed packages, you will find useful packages like and libraries like Bokeh, BOKEH, which is an useful library, interactive web visualization library. And then there are other useful packages which have been installed like Glob2, Ipython, Jupyter Lab, which is an enhanced version of the Jupyter notebooks. The Jupyter notebooks are web-based notebooks which we will be extensively using during this training program for interactively writing the code, executing the code, and seeing the results, visualizing the results, then saving those notebooks and sharing with others. Like we will be sharing the Jupyter notebooks with all the participants for self-practice. So Jupyter Lab has also been installed. Then there are other packages like Matplotlib, which is a useful two-dimensional plotting library in Python, and NumPy, which stands for numerical Python, which is useful for numerical computation. It provides n-dimensional array element, which is this NumPy forms the basis for many other third-party packages, open source packages such as raster, stats, rastereo, which are useful for dealing with raster data. Now, as you will be seeing that raster data is represented in the form of multi-dimensional arrays, and therefore the n-dimensional array of NumPy is useful for dealing with raster data. And then there is pandas, which is a very useful package for dealing with tabular data. It is very useful for data analysis. And then there are other, like Python has also been installed, Python 3.9.12. Then there are other Python packages like scikit-learn, which is a Python module for machine learning. Then there is SciPy, which is useful for scientific computing. Then Seaborn, which is useful for statistical graphs, and so on. These are the various packages, Python packages, which are installed along with Anaconda distribution. Then you can also launch Python interpreter from the Anaconda prompt using this command Python, which will launch Python interpreter, the version which is installed along with Anaconda distribution, that is 3.9.12. And just as we had seen in the online Python interpreter on python.org, you can type simple codes and execute them, like addition of numbers, printing of customary hello world statement, etc. You can exit Python interpreter with this command exit, then parenthesis. Similarly, you can also access Ipython, which is an enhanced Python interpreter. And you can write simple, again similar codes like this. As you can see, the enhanced features, the input and output in various colors, and then there are other enhanced features like help options, then auto suggestion, auto completion of the code. Jupyter notebooks are actually an outcome of this Ipython project, which you will see that they will have this similar input output format. So that is you can exit Ipython using the same command exit and then parenthesis. In case if you want to execute a long program with many multi-line code, you can save that as a file with .py extension in the same folder containing the Anaconda 3 folder under in users. Then you can execute multi-line code with the command python space the name of the file, which can be anything, then .py. Then it will execute the multi-line code. If you want to exit the Anaconda prompt, the command is the same, exit and then parenthesis. As already been discussed, we will be creating a new environment and then we will be installing Python packages using Conda installer in that new environment from the Conda force channel. So for creation of the new environment, the command that we have to launch again the Anaconda command prompt and then use this command conda space create space -- then space the name of the new environment. In this training program, we will be creating a new environment python-wrm, short form for water resources management, with a specific version of Python. Now, as you have already seen that Anaconda distribution has already installed Python version 3.9.12 on your system. However, if you want to create a new environment with a specific version of Python, you can do that. On the same system, you can have different environments with different versions of the Python and various packages, versions of the packages, Python packages installed, and it will not lead to incompatibility issues. Uh, so it is very important to create, whenever you are starting a new project, it is very important to create a new environment. So we will see, we will demonstrate creation of the new environment using a specific version of the Python. Then once you create a new environment, you can see the listing of the environments other than the base environment using this command conda space info space double dash envs, the short form for environments. Then it will list out all the environments that have been created in addition to the base default and root environment. Then you can activate any of the newly created environment using this command conda space activate space the name of the environment. In our case, the name of the environment is python-wrm. Once you created a new environment and with a specific version of the Python and you activated that environment, you can start installing packages, Python, various Python packages in that new environment from the conda forge channel using this command conda space install space dash c, which is the short form for channel, space conda dash forge, which is the name of the channel, community channel, from where we will be installing various packages. You can go in one go, you can install many packages by separated by spaces. Like you can use this command, and then in place of package name you can you can write the name of the package and then space and another package. Then it will install all those packages. Now these are some of the indicative list of packages which we will be installing. Now we will not be using all these packages during the training program, and also some of the packages, like for example GeoPandas is a third party package which has dependencies on other packages like Shapely and then Pandas. When we install GeoPandas, it will also install its all the dependency packages like Pandas and Shapely. So even then, what we will do is for practice purpose and for you to get used to, you can start installing all these packages one after another to get used to the process. And in the this is a tough way of getting used to the command line Anaconda command prompt. In the We will be seeing also how we can do the same thing like creation of environment and installation of packages in the new environment, making use of Anaconda Navigator in the next session. Now let us see a demo of creation of a new environment using specified version of Python, and then how to activate that environment, and then how to install various packages from a Conda Forge channel in that environment as shown in the previous slide. We can start by launching the Anaconda command prompt from the startup menu. And here you can, as you can see, the current active environment is the base environment, which is the default environment. And now you can write this command for creation of the new environment: conda space create space dash n space the name of the new environment, which we want to name it as Python dash wrm, and then space. And I want to install this new environment with a specific version of Python uh, equal to 3.8, which is different from the version which was installed along with Anaconda distribution in the base environment. So, and then you press enter. So it says the Conda version, latest version available is 4.14.0, which you can update using the command conda space update space conda. However, now we will go ahead with the creation of new environment. Every time it will be for creation of the new environment, these following new packages will be installed, and it will every time it will ask you whether to proceed further, and you have to press Y and then press enter. So the new environment has been created. You can check you can check it by listing the all the environment list of environments using this command conda space info space dash double dash envs. It will list out all the environments. Like here, as you can see, there are two environments: the base environment, which is the default environment, and it is also the activated environment as indicated by this asterisk sign, and then python dash wrm is the new environment which we have created. Now we want to activate this new environment. For that, we will use the command conda space activate space python dash wrm, and then press enter. Now, as you can see, the python wrm dash wrm environment has been activated as indicated by this the name of the python dash wrm environment within parenthesis preceding the command line. You can also check by again listing out the environments conda space info space double dash envs, which will list out again it will list out the two environments, and the active environment python dash wrm, you will find it with asterisk sign. So we have we have created a new environment with a specified version of python 3.8, and then we have activated the environment. Now within this newly created and activated environment, we will be installing various python packages. We can start with this command conda space install space dash c space conda dash forge, and then the name of the package separated by space. We will install numpy to start with. So when you press enter, it will list out all the dependency packages for numpy. It will also install those dependency packages along with the numpy, and every time it will ask you whether to proceed further or not. Every time you have to press Y and then press enter. So numpy has been installed. Similarly, you can start installing one package after another as shown in the previous slide, and there is a shortcut. Instead of typing all the full command, you can use the upward arrow button on the keyboard, which will show you the the previous command which you have run, and then you can replace numpy with the next command next package that you want to install. Like you can go ahead with pandas and then press enter. And again the pandas has these dependencies. You can press Y and press enter. So in this way you can go ahead and complete installing all those packages. Now let us conclude this first session here. You can go ahead to install all those Python packages in the newly created environment. It will take some time. And in case if you encounter any issue, you can raise the query in the WhatsApp group or in the e-learning platform course forum. In the next session, in the second session, we will be seeing an alternative to this Anaconda command prompt. We will have a look at Anaconda Navigator, which is a guided user interface for doing the same things like creation of environment and installation of packages in that environment. And then we will see the Jupyter notebooks, an introduction to Jupyter notebooks, which we will be using all through the training program, and then we will cover the basic data types in Python. Thank you very much.